Okay, so we're going to have another Physics 2 problem here working with the E field. So with this, we have a point charge at 3, 6, where this is our Y, this is our X, and we'll let them both be in units of meters. If they're not, you would just convert them. So we have a point charge that has 30 microcoulombs at the point 3, 6. And our question is, at the point -5, 12, what is the magnitude of our E field? So that's really what we're looking to solve here. Now, the equation we're going to use is that your E field is equal to K, the absolute value of your charge, divided by the distance squared. Well, we know Q, that's the 30 microcoulombs. K is just a constant. The real thing we want to find here is the distance R. So how do we find that distance? Well, we need to go down 6, and we need to go over 8. And what we're interested in, what R really is, let me even maybe add, do I have a different color? Let me add a pen. Let's do this dark color. Well, that's very light, but this line connecting them is R. Gotta make that a little thicker so everyone can see it. This, even though it's very thick, that is actually R. Okay, so how do we find R from this point? Well, there's a few ways to do this. We know that the change in height from 6 to 12 is 6, and the change in X goes -5 to 3, so that's 8. This is a right triangle, so if we want to find the hypotenuse, we know the hypotenuse, in this case R, is equal to the square root of 6 squared plus 8 squared. You could also use the distance formula, but I'm going to go ahead and just use Pythagoreans. I think it's a little easier. So you're going to plug that in to get your R value. Now, once you have your R value, you're pretty much set up to go. The only thing you need to do is plug everything in after that. So the number should work out to be, so R ends up being about 10 meters. And then if you plug this in, so this is your R that goes into here. K is a constant, Q we know. If you plug all that in, the E field at that distance should be 2.7 times 10 to the third newtons per coulomb. So that's all there is to it. The big thing here was just finding that distance R, this distance R, which we just used Pythagorean theorem. And then once you have that, you're pretty much set up. Just know your equation. That was for a different problem. And that's it. That's all there is to it.